All right, so in this lab here, we're going to be investigating different intermolecular forces between three solutions. We have tap water, methanol, as well as a soapy water solution here. The way we're going to be doing this lab here is we're going to be using these droppers here. Individually, we're going to be dropping little droplets on top of these pennies here. Because there's a lot of sort of random error in this experiment here, I have sort of 3 pennies laid out here so that I can do 3 trials of each solution, and that way I can hopefully average the results a little bit better. Because I am comparing the 3 different liquids, I want to make sure other variables are constant. Say temperature I want it to be constant, the sort of pressure around the room here to be constant as well. It's always good to even record down what is the control variable. So for example, for my thermometer here, it's reading 20.0 plus minus 0.5 degrees. You still record that down as your control so that if someone sort of questions your results later on, you can actually mimic back and repeat your procedure again. So the way we're going to do this here is I'm going to individually take the solutions here. We're going to start off with water. Other control variables I'm going to want to keep is I'm going to want to try to apply the same amount of pressure to the top of the dropper, so the drops come out at sort of the same speed and the same size here. I'm going to try to balance these droplets here on top of a penny, and what I'm going to do here is I'm going to count until the water drop actually falls over. That would be a sign of the intermolecular forces weren't enough to sort of fight against gravity, and that's when we would take our measurement. So I'm just going to demonstrate how this is going to be here. Again, other things I want to control here, I don't want to have some droppers a lot higher up, some that are a little bit lower down. I'm going to want to keep maybe about a 1 centimeter height here. I also want to make sure that the angle is sort of constant between the 3 different solutions. So I'm going to try to hold it about 1 centimeter high. Already there's been 1 drop here, and then we're just going to count how many droplets afterwards. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and there you go. So something about 21 here. Again, you notice a lot of fluctuation based on my drop size, so that's why we're going to repeat the trial here. So trial 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. There we go, so about 23 there. One last trial here. You'll notice that the pennies are all the leaf side up, so I wanted to sort of control the surface area a bit here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, about maybe 26 there. Okay. So those are the 3 trials here. If the variability between trials here was very wide, I might go and do a 4th trial or a 5th trial. Let's move on to the methanol solution here. So methanol, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and you already start seeing some leaking there. Okay, so 15. Okay, reload my pipette here. Again, try 1 centimeter high. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, or maybe about 15 or so. Sometimes it's just sort of splashing as I'm sort of just lowering the methanol solution, so we need to look out for that there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, maybe somewhere around 10 or 11 for that one there. You're going to find that methanol, the dropper even has trouble actually holding the solution inside. That's a sort of qualitative observation we could make. Maybe the intermolecular forces are not as strong as, say, in a water solution. For a soap water solution here, although soap has a really complicated chemical structure, do remember that there was a lot of water here before I added the soap, so we're just trying to ask ourselves how does soap actually interfere with the water molecules. It comes in between the waters in affecting the surface tension, the intermolecular force. So soap water here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, maybe about 19 there. Okay, reload the solution here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, maybe it's about 17 there. Okay, one more solution here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, maybe about 13, 14, 15, 16 maybe, right? Again, if the droplet number is varied between the different trials, it may be good to actually redo that trial. In chemistry, we try to do what's called a 5 by 3, so 5 different measurements. So if I were testing 5 different solutions, those would be the 5, and for each solution we do it 3 trials. Again, nothing magical about that number 3. If it's too varied here, you can always do another trial there. As you start thinking about the design of this experiment here, when you start talking about error analysis and what you can do differently next time, although I tried to control variability like the surface area of the penny or whatnot, you can sort of ask yourself, would it be better for me to have used one penny and clean it off in between, or the way that I did it here? When you talk about errors, make sure you use terms like random errors and systematic errors, and then try to go beyond just saying, oh, let's just use better droppers, better equipment, let's use steady hands and things like that. All of those things here are true, repeat trials, things like that, but try to think about the procedure, the design of this experiment, and see if there's anything that you can do differently the next time. Thanks, guys.